Happy Friday, everybody, and welcome to our math class. Today, we're going to discuss lesson 5.3, and it's about special parallelograms. Yesterday, we have talked about parallelograms. It has two pairs of parallel sides. And today, let's talk about the special parallelograms. We have the rectangle, the rhombus, and the square. Now, to start with, let's recite today's memory verse, and it's found in Isaiah 11, verse 12. It says, "And he will lift up a standard for the nations and assemble the banished ones of Israel, and will gather the disappeared of Judah from the four corners of the earth." You see, sometimes, if you remembered Christopher Columbus and the rest, who said that the earth was flat because they believe the earth has four corners, the north, south, east, and west. So they imagine that the earth is just flat. It's possibly a rectangle or a square. And they believe that once you will travel from one point to another point, there will be a point where you will vanish. You'll be at the end of the corner. And it was Christopher Columbus who first navigated the world. And he proved that that the earth is round and you can travel from east to west. For today's MBCA boosters, it's about the expression fair and square. A common expression states, "win the competition, fair and square." What does the expression fair and square mean? At the end of today's class, you'll be able to do two things. First, use the properties to find measures of angles, sides, and other quantities involving parallelograms. And the second is prove theorems on the different kinds of a parallelogram. And let's start. You see, this is what we call the quadrilateral tessellation. Now, what is a tessellation? Have you seen tiles? Tessellation is similar to tiles. It's called tiling. It is a pattern made by shapes called tiles. And the pattern continues. The pattern can do like this one, like the tiles, and do this one again. In different angles, in different positions, as long as there are no empty spaces. And tiles never overlap. Here are some examples, like the first one. Actually, this is a quadrilateral. That's 1, 2, 3, 4. So that is a quadrilateral tessellation. The other one, there are two shapes. The other is a pentagon, the blue and the green. But if you see the white one, it is a rhombus. Then we also have here, these are kites, 1, 2, 3, 4. And the other one, these are different quadrilaterals being tessellated. So you see, even in tiling, even in patterns, you see mathematics. And have you seen a honeycomb? A honeycomb is also made of hexagonal tiles. And I think many of our houses, our floors are tessellated by quadrilaterals. Now let's talk about special parallelograms. I told you there are 3 special parallelograms. If it's a rectangle, it has 4 right angles. All 4 angles are equal. If you say rhombus, all 4 sides are equal. Now, if you say square, remember a square is a rectangle. It has 4 right angles, and a square is also a rhombus. It has 4 equal sides. So we say that the square is both a rectangle and a rhombus. It has properties of the 2 special parallelograms. So whatever is true to the rectangle is true to the square. Whatever is true to the rhombus, it's also true to the square. So again, a square is both a rectangle and a rhombus. So if I'll ask you, is a square a rectangle? Yes. Is a square a rhombus? Yes. But is a rhombus a square? Sometimes, right? Now let's go to the properties. I have here the rectangle, the rhombus, and the square. Example, opposite sides. In a rectangle, opposite sides are congruent. Let me first get my pen for a while. Okay, here, in a rectangle, opposite sides are congruent. So these two are congruent, the other two are congruent. The same for the rhombus. Opposite sides are congruent. These two are congruent, these two are also congruent. The same is true for the square. Sorry, my eyes are so itchy. For the square, opposite sides are congruent. The other pair of opposite sides are also congruent. So again, for the rectangle, rhombus, and square, opposite sides are congruent. Let's go to their consecutive sides. It's blank here in the rectangle because their consecutive sides do not have any relationship. But for the rhombus, consecutive sides are congruent. Like these two are congruent. Same is true for the square. Consecutive sides are congruent. Let's go to the opposite angles. For the rectangle, opposite angles, remember, it's all 90 degrees, right? So opposite angles are congruent, they are the same, and supplementary. It means their sum is 180 degrees because each angle measures 90. For the rhombus, here, opposite angles are congruent, but they are not supplementary. For square, I told you that the square will take both the property of the rectangle and the rhombus. So you see what's common? Congruent and supplementary. So it means that the opposite sides of a square are congruent and supplementary, just like the rectangle. Next, for consecutive angles. For a rectangle, both are still 90, so consecutive angles are congruent and supplementary. For the rhombus, these two, they are not congruent. They are just supplementary. So their sum is 180 degrees. You know what? Why I'm drawing this? Because I don't want you to memorize all of these theorems. I want you to visualize. So for example, if I'll say, okay, how do you describe the consecutive angles of a square? So what can you do? You can draw a square, draw two consecutive angles, and check. Are they congruent? Yes. Are they supplementary? That's 90 and 90. Yes. But for rhombus, only supplementary, not congruent. So you see, once you draw the figure, then it's easier for you to remember the theorem. The next one, the last one, for the diagonals. I suggest you, sorry for my drawing, I'm not so good. You draw the diagonals here. They are of the same distance. So we say that in a rectangle, the diagonals are congruent. Then what is the basic property of a parallelogram? the diagonals bisect each other. So you see, because the rectangle, the rhombus, and the square are diagonals, then there are parallelograms, then their diagonals bisect each other. Next, for the rhombus, let's draw a rhombus. In a rhombus, the diagonals are not congruent. But if you investigate, the diagonals are perpendicular to each other. And since they are perpendicular to each other, each diagonal of a rhombus bisects two angles. So for example, in this diagonal, this angle is bisected. What do you mean by bisected? It means it's cut into half. So if this angle measures 100 degrees, then with this diagonal, this one becomes 50, and the other one is also 50 degrees. The same is true once your diagonal will be moving here. So if the whole angle measures 80 degrees, then with the diagonal, it cuts it into 40 and 40. Now remember, the square takes both of the properties. So for example, in the rectangle, diagonals are congruent. So here, for the square, diagonals are also congruent. In the rhombus, diagonals are perpendicular. So for the square, diagonals are also perpendicular to each other. So they take it on the rectangle and the rhombus. And the last, the same with the rhombus, the diagonal bisects two angles of the square. Now, any questions? Now let us have an activity. I'll place in the chat box. Let's do the emotions, okay? In the emotions, with your emoticons, you press heart. Let me just write it here. You press heart if it's for rectangle. You press, what else do we have in our emotions? Emoticons. Reactions. Okay. You press teary eye if it's only for rhombus. Then, sorry, I don't know how to draw thumbs up, so clap. Clap na ha, clap. If I'm describing a square. Okay? Ready? Again, you show me the best description. Okay, let's start. The first one. Opposite angles are congruent. Opposite angles are congruent. Heart, teary eye, or square. Opposite angles are congruent. How about the rest? Oh, very good. Actually, it can be a rectangle, it can be a rhombus, it can be a square. So all of your answers are correct. The second one. Consecutive angles are congruent and supplementary. Consecutive angles are congruent and supplementary. Consecutive angles are congruent and supplementary. Let me check. Okay, so it can be a square and it can be a rectangle. Next, consecutive sides are congruent. consecutive sides are congruent. Consecutive sides are congruent. Very good. It can be a rhombus or it can also be a square. How about the rest? What happened to you? Next, the next one. Diagonals are perpendicular. Diagonals are perpendicular to each other. Diagonals are perpendicular to each other. Oh, the correct answer is it can be a rhombus, a smiley, a sad face, or a square. The next one, the diagonals are congruent. The diagonals are congruent. The diagonals are congruent. It can be a rectangle or it can be a square. Okay, now thank you so much for participating. Let's go to the next one. Now, let's do these exercises. Let's have the first one. Quadrilateral care, C-A-R-E, is a rhombus. Find the measures of angles 1, 2, 3, 4, and 5. The given is angle C is 72 degrees. Okay, this is a rhombus, so all equal sides. Now, remember that in a rhombus, the diagonals bisect the angle. So if this is 72 degrees, then angle 1 is half of it. So we have 72 divided by 2. That's going to be 36 degrees. So the measure of angle 1 is 36 degrees. Ma'am, why do you place M here? If there's an M, it means it's a measure. So it means that you need to have a numerical value like 36 degrees. But if you only have angle 1, we use that to say angle 1 is congruent to angle 2, just to describe. But if there's a measure, you need to write M before. So this is 36. The other one, the measure of angle 2 is also 36 degrees, right? Now next, remember angle C, wait. Angle C and angle R are congruent. Remember, opposite angles of a rhombus are congruent. So this is also 72 degrees and half is 36. So angle 5 measures 36 degrees. Next, angle 3. And remember that the diagonals of a rhombus are perpendicular to each other. Therefore, the measure of angle 3 is 90 degrees. The last is angle 4. If this is 36, this is 90, we're looking for angle 4. There are two ways to do it. The first way is, remember, this is a triangle. And the sum of all angles in a triangle is 180 degrees. So you can add 90 and 36, then subtract it to 180. That's 180 minus 36 minus 90. So our answer will be 44 degrees. Or here's another method. Another method, remember that consecutive angles are supplementary. So if this measures 72 degrees, angle E measures 108. Am I correct? Sorry, dapat 54 di ay. 54 degrees. Sakto. Yes. 49. So now, remember that these two are consecutive angles. So they are supplementary. So if angle C measures 72 degrees, angle E measures 108 degrees. And the diagonal of a rhombus bisects the angle. So angle 4 is half of it. So angle 4 is half of 108. That's 54 degrees. The same with the other one. Questions? No questions? Let's go to the next one. The diagonals of rhombus care, C-A-R-E, have lengths 8 cm and 6 cm. What is the length of each of its sides? Now here, remember that in a rhombus, the diagonals bisect each other. So if this is 8, then half is 4, the other is 4. Let's name the center point O. If this one is 6, then that's going to be 3 and 3. We're looking for the measure of this one, the side. And we got a triangle here. So with our triangle, it's going to be 3, 4, and this one is missing, CE. Now, remember that in a rhombus, the diagonals are perpendicular to each other. Therefore, what we have here is a right triangle. I want you to remember the Pythagorean theorem. You have this in your grade 8, and I want you to remember it this time. What does the Pythagorean theorem states? The Pythagorean theorem is used for right triangles. The small a, and the small b are called the legs, while C is for the hypotenuse, the slanting part. The Pythagorean theorem states that the square of the hypotenuse is equal to the square of both legs. So that's C squared equals A squared plus B squared. Or from there, you can make it C is equal to the square root of A squared plus B squared. Now in this triangle, our A is 4, or it can be 3. They can interchange. And our B is 3. Our C is missing. So let's solve for side C. You have C squared equals A squared plus B squared. So we have 4 squared plus 3 squared. That's going to be 16. Then 3 squared, 3 times 3 is 9. That's going to be 25. But remember, our chapter 1 lesson is on extracting square roots, right? Square root one side, square root the other side. So C is equal to 5. It's supposed to be plus and minus 5. But we only take the positive side, positive number for the measurement. So the measure of C, of each side of CE, is 5 cm. Since this is a rhombus, then each side measures 5 centimeters. Any questions? Let's go to the next problem. Quadrilateral give, that's GIVE, is a rectangle. Let's repeat this one. Now, GV, here the whole is 5x minus 3. EA, up to here only, is 2x plus 3. But remember, in a rectangle, diagonals bisect each other. So if EA is 2x plus 3, then AI is also 2x plus 3. So let's now have this one. GV is congruent to EI. GV is 5x minus 14, while EI can be summed as 2x plus 3 and another 2x plus 3. So for the right-hand side, we have 4x plus 6. Let us now transfer it. 5x minus 4x. The other side equals 6 plus 14. So x is equal to 20. Let's go to exercise number 4. Quadrilateral pure is a square. So these 4 sides are equal because it's a square. If the measure of EU, where's EU there? EU is 40 centimeters. What's the measure of EA? It's very easy, right? The diagonals of a square bisect each other. So EA is half of EU. That's going to be 20 centimeters. Let's go to the last problem. Quadrilateral pure is a square, so congruent. If the measure of angle PEU is x squared plus 26, just this angle, find the value of x. Now remember that this is a square, so all angles are right angles. And the diagonals of a square bisect the angle. So if this whole is 90, then half of it is 45. So we place x squared plus 26 equals 45. We do transposition. X squared equals 45 minus 26. So x squared equals 19. We extract the square root of both sides. So x is equal to square root of 19. Any questions before we end our discussion?